day to you. This is Anagalactic bringing you the second in our wrap-up sequence, a synthetic sequence to explain and show a new number system for spherical space, which is now required in physics. In the last lecture, we got as far as proving the existence of a spherical number system. To recap that, we now have a center to the universe that is not zero, which is the additive identity, but it is the so-called multiplicative identity, which turns out to be the number 1 in the shape of a sphere. The reason for that is we have the definition of the infinitesimal, which finalizes the definition of the infinitesimal, ending 3 centuries of controversy. The center of the system is 1 over infinity, and the edge of the universe is infinity over 1. This rationalizes the universe and supports Max Planck's discovery that the universe is finite and uses a rational finite number system. That's how we know that the universe is finite. Now we need to know where these numbers are and what they represent. That is called the metric of the system. As I taught you in the last lecture and in several lectures before that, the metric of linear space, the linear number system used exclusively in science, is based on the number 1, which is a distance from 0, and the metric is called linear spatial separation. The advantage of the number system that we've devised now, which is antecedent to the linear number system, is that it is a 2-component number system. These are called rational numbers. The basis of the number system itself is a 2-component rational number system, which means that the base is 1 over 1 times 1 over 1. That represents the surface of a sphere, which is harmonically halfway between the center and the edge. If you have the center, which is the infinitesimal, 1 over infinity is an imaginary number. This matches physics for the first time. The edge of the universe, which nobody has ever been able to rationalize, is now rationalized on the reciprocal of the infinitesimal, which replaces 0. The number at the edge replaces the older ideas of infinity, such as of Cantor and Dedekind, and of course the astrophysicists, who are now proved to be essentially out of their minds. That's not clinical, that's not psychiatric. It's a break with reality. Science is ruthless this way. So we now have a bounded spherical space with a center. The center is not 1 over infinity. That is the geometric center, and it takes the place of 0 and represents the only rational definition of a point. And that is the only point in the spherical system, is the center of the sphere. However, the sphere itself, having a unit value, our concept of 1, which is unity, that is the spherical surface, and there is no interior. And that is the quantum paradox stated geometrically, that the center of the universe, which you may now call the quantum, it does have a radius, but there's nothing in there. It's neither space nor time. And now we're going to discover where space and time exist, according to Albert Einstein's discovery of the orthogonality of time with space. Albert Einstein found the linear solution for gravity. It's called general relativity, and it is now the basis of modern science. Correctly so, if you wish to stick with the ancient 2,000-year-old, now outdated and absolutely worthless system called linear algebra. It's not useless on Earth. The Industrial Revolution proved that with the addition of a special tool system, basically called the calculus, we can get anything we want on Earth. That has deluded the sinful minds of men who are now incorporated into a group mind, which is now dedicated to unearthing somehow the next weapon, which is beyond fission and fusion, both of those being the result of the discovery of quantum mechanics, and the conquest of outer space so we can begin Star Wars, which will be, of course, destructive to the Earth. That is the result of linear algebra when it's applied to cosmic space. We have to find the right solution. So, where we left off in the last lecture, we have the center number and the edge number. Infinity over 1 bounds the universe, and 1 over infinity bounds it at the other spheric edge. There are 2 edges, and that makes 1 axis with a chiral basis. We're coming to that, but we have not yet rotated the sphere. So to begin today, we have a surface value of 1 at the center of the system, with nothing inside. However, that raises a question: what are the unit fraction numbers? We know what the whole numbers are. Max Planck proved that the counting numbers of the universe are whole counting numbers. The lowest number is 2. That is the lowest frequency. But you know from physics that with a frequency of 2, that immediately posits another number, 1/2, the wavelength. That's called the wavelength-frequency relationship. Those 2 numbers multiply to 1. That's where we begin today. The universe is a unit, and it's based on unity. There is no such thing as nullity. There is no 0 in the universe, and therefore the number 0 that we use in our linear system, which is used to represent the Big Bang origin, and it's also used to represent the center of the supermassive black hole. Those are nonsensical geometric constructions. They posit the inversion of physics. That is called anti-physics. So we want the actual physical universe based on what the physical universe says about itself, not about what men say using their 2,000-year-old Greek stick system with a 0 at the center, which is only capable of measuring linear, spatial separation. Albert Einstein said that is not good enough. What he did by composing in pseudo-hyperbolic space a 4-number system using time as an imaginary negative number, where the 3 lines that make cubic space are all positive and time is negative. That permits the introduction of quaternion logic, which is the 4D extension of 2D complex logic, each of which has its own algebra. In order to make this work, to compute spherical space, which indeed gravity posits, gravity is a spherical centripetal force, and Albert discovered by thinking very carefully about simultaneity in gravitational space that he could linearize time into already linearized spatial system. That works if you use calculus. It's for tensor calculus, and you have to have a geometry for it. That's called pseudo-hyperbolic space. We don't want that because it's linear. It's the linear solution for a spherical phenomenon, which is a force. In the Einsteinian system, gravity is called a pseudo-force because it appears to be passive. That's an illusion, and that's why it's been so highly controversial. In not really a philosophical sense, but a physical sense, gravity is a force. It's a centripetal force. But the way it manifests is by bending space. And that is actually correct. We will show that that is the correct interpretation of the integral of protonic centripetal force. It is the particle called the proton that bends local space. When mass forms a large enough entity which has an indefinite inner limit to that, you get something like the Earth or the Sun. These are spherical objects because the protonic integral force of the mass that collects itself together according to its own mutual attraction, that forms a gravitational field, and that's spooky action at a distance. We are now going to discover the geometric and numeric basis of that force. It's obviously spherical. The reason why Albert had to use pseudo-hyperbolic space is because of the inversion of the valence of the time pseudo-vector. It's an imaginary vector. Time is imaginary in the space-time system. We cannot use that. There is such a thing as imaginarity. There is such a thing as that which we cannot see or even compute directly. But in order to understand what that is, we first need to understand the force balance of the universe. That will come out in this lecture as we continue our expansion of the axiomatic basis of science, the new axiomatic basis which I've discovered. The linear system is embedded in spherical space. The antipodal theorem proves that. When you draw a straight line in metaspace, it hits two infinities, you get the center out of that, and from that you can deduce that the embedding space is spherical. And therefore the diameter has a linear component. You can cut that in half and you have the radius. That would be more accurate. But we use either one. That's why we have both pi and tau for the circle, extended, of course, to the sphere. Those are both irrational numbers. We are now capable of recomputing the basis of numeric and geometric space rationally, solving the irrationality of the edge of the universe and solving the irrationality of the quantum simultaneously. So we've already done that, and now we need to demonstrate how this addresses physical properties. These will be two forces. We've already discovered centripetal force. Gravity is the integral of protonic force. The reason we know that is the only centripetal force that we can see is gravity. But it's based on mass, isn't it? You know how mass is defined? Protons. Protons define mass. Therefore, the proton, which in its tiny local space, measured in femtometers, manifests a centripetal force of the proton. It's bending space with respect to electronic force. The electrons form shells around the protonic core. The simplest system is one proton with one electron. That's called hydrogen. It's actually simplex hydrogen. And that one electron forms a spherical shell at an exact distance. That distance may be considered in our geometry to be 1. But it's not the radius. The spherical surface is 1. The interior of that could be said to be imaginary. That's a contradiction according to our perceptual system. And this is where it gets extraordinarily spooky. So let's begin rationally and continue rationally until we hit the spukhafte Fernwirkungen, which is manifest both in gravity and in light. Light is a centrifugal force. And if you think about it, I think you'll realize it is the only centrifugal force in the universe, an intrinsic force. These two forces are balanced completely, and we're going to prove it using spherical geometry. And this will answer a lot of paradoxes and a lot of unsolved questions. So where we left off in the last lecture was with an imaginary center called 1 over infinity, balanced with an imaginary number at the edge, infinity over 1. Infinity over 1 is larger than 1. 1 over infinity is less than 1, it is called a unit imaginary fraction. And it's the only unit imaginary fraction. Just as infinity over 1 is the one and only integral imaginary fraction. Everything in between those two numbers, the center and the edge, both of which are imaginary, are real. And this is the correct definition of a real number. A real number is a rational number. This was discovered by Max Planck, who unearthed, to me this is the greatest discovery in the history of physical mathematics, or physical science. He discovered it in the year 1900. The relationship between the frequency and the wavelength of light is directly related to light speed, such that the lowest frequency in the universe must be 2, and that is the quantum. However, the quantum numbers are two-component numbers. We discovered that in the last lecture. And the first counting number, equivalent to 1 in linear space, which is measured from 0, this is spherical space, which is measured from 1, and it splits. According to our innate linear logic system, which we were blueprinted with, you can make a logical case for 1 over 1 being the surface of the sphere, and when it splits, the 2 goes out, that would be frequency, and the 1/2 goes in. Why? Because 1/2 is less than 1, and 2 is greater than 1. And if you think about that for a moment, you'll realize this is Zeno's paradox, that as you go out, you cannot reach the edge. There is an edge, though. It's an imaginary number, and therefore there is a highest frequency. That has not yet been discovered. It's considered to be now, according to our scientific nomenclature, to be in the gamma range, which is a very, very high frequency, which means a very, very short wavelength. Well, you can see that from the center, that the fractional numbers, the wavelengths, will go in proportionally. As the frequency goes out and gets larger, the wavelength gets smaller, but it never reaches the center to the proportion that the frequency never reaches the edge. That's very simple, and it's rational. It makes sense, but now we need the metric. The metric for linear space, measuring from 0 on a line, is 1. And the definition of the metric is linear, spatial, separation. Albert Einstein made a tremendous discovery concerning the relationship between space and time, such that time can be linearized with respect to space, but on a 180-degree valence inversion. This would be the equivalent of negative and positive. That's 180 degrees. If you go this way, or if you go this way, those are opposite directions on a diameter, correct? All right. In linear computation, only one of those is considered to be positive. Only one of them is real. That would be the positive 1 direction. The negative 1 direction is a reflection. And that's proved useful in composing complex numbers. And I won't go into that. I have several lectures devoted to the complex number system, which is an extremely useful tool. What we were left with in the last lecture is the number 1, which is a sphere. Inside the sphere, since it does have an interior, the line does not have an interior, but the sphere does. And those would be the unit fractions, but you can see the radial line that goes out in all directions at once, which would be the integral line with respect to spheric space. This has to do with the calculus. This solves for the calculus. We use the derivative number system by drawing one line. That gives us the radius and the diameter, introducing linearity into spherical or circular space. We don't want that. We want rational space. Therefore, by beginning with a multiplicative divisional system called proportional space, instead of additive space, we use multiplicative space as it's called in mathematics. The correct term is proportional space. You have a two-component number system generating a sphere from the two imaginary numbers that we created axiomatically. And that creates real space. Now we need to prove that. It makes intuitive sense so far. It matches physics exactly. The line, absolutely not. So, we've already made progress, but there's something missing. Albert showed us what it is, but it has three names. He called it time. And this, of course, is the space-time formulation. That's a pseudo-hyperbolical system where the function we call light speed is a cone with 0 at its center. And that is incorrect. It would have to be. He's using 4 lines. It's linear. That won't work. It's spherical space. What we will find out today is that instead of the light cone, we have a light sphere. And that is the surface of time. Now that's going to sound baffling, but anything that is said from this point forward is going to be baffling. We are going to de-baffle it. It's called disambiguation. You're going to have to think until I give you the proof. And then you have to think through the proof to make sure it's a proof. So far, we have a rational system. All of space in this spherical system is filled with numbers. Going out, they are shells. That does match the quantum system we see in the atomic system, which is composed of spherical shells based on a centripetal force. When light leaves an atomic system, it departs from one of the shells with centrifugal force, and those are the two forces. Light manifests centrifugal force, and gravity manifests centripetal force. But here's where it gets peculiar, because they're incommensurable systems. And therefore, the right way to think about it to begin with, until we get to the proof, is that the protonic system, that is the nuclear core composed of anywhere from 1 to over 100 protons, you can't get too many more than that, or it starts to fission by itself. It falls apart. The binding energy of the strong force, nomenclature has changed somewhat, but the binding energy of nuclear cohesion, when there's too many protons, it starts to split, and that's called fission. But in the simplest system, called the hydrogen simplex system, it's 1 proton, and that's most easy to visualize. You have a center, and that's monumentally profound. If this particle, called the proton, manifests a center of space, and it bends space, and that's the right way to think about it. What about light? Light traverses space, we think. In fact, we know it does. But it does something much more peculiar. It does so basically at the speed of time, and it's the only particle that does so, and therefore it cannot be a particle. Now, Albert Einstein proved that it can be considered a particle, and this is the quantum paradox restated, that a photon is considered to be a particle. But that raises spukhafte Fernwirkungen when the photon reaches your retina, or the photographic plate from a distant star, for instance. It collapses the wave function, because Christian Huygens proved, at the same time that Newton was considering light to be corpuscles, that is particles, Christian Huygens proved that it's also a wave, and that paradox has never been resolved. It is called the quantum paradox, which is most easily visualized as when, what did Christian Huygens prove? It's a spherical wavefront. When EMR, electromagnetic radiation, radiates from the atomic system, that's where light comes from, it goes out in a spherical wavefront, which means that by the time it reaches your eye or your photographic plate from however many light years away, if you're photographing astronomical objects, it has a radius. It's not just a linear function. It's a spherical surface that's reaching your eye or photographic plate. And when it recontacts an atomic system and is absorbed by an electronic shell, that is what happens. It collapses the sphere, and that's called the collapse of the wave function, and that's what Einstein really didn't like. For obvious reasons, he had already discovered that light's speed is absolute. Yes, it is, but you need to know exactly how it's absolute. the photon is a very peculiar thing. So, to recommence our axiomatic beginning with a new geometry called spherical geometry, which I discovered has a spherical number system, we now need to get the metric of spacetime. One of the components we already know. The shells go when you get the index, which is the first counting number in the system. For linear space, that's 0 to 1. In spherical space, instead of 0 being the center, 1 is the center. And the two numbers split. So it's a two-component number system instead of a one-component number system. I think you're starting to see pretty clearly why nobody has been able to penetrate this paradox. We're going to penetrate it right now. When you conceive of the center of any system as being a sphere with nothing inside, then you have to decide what are the unit fractions doing. Because in a 180-degree valence, if you have the radial line going out, that would be light. Or going in, that would be gravity. And those are centripetal and centrifugal forces. It's either being pulled in or it's being pushed out. But what is being pulled in? These are incommensurable. Time and space are two different data types. It's just somewhat miraculous, and we can thank the universe. As scientists, we don't say God, but you could thank superintelligence or whatever is responsible for making the universe the way it is. It's up to you in your spare time to figure out how to deal with that. But this is miraculous. Indeed, the linear number system is miraculous. It gives us anything we want on Earth if we use the calculus. And with the help of supercomputers, we literally can get anything, and that will destroy the Earth. But it could have saved it. It won't. It'll destroy it. But that's okay. That's all part of some bigger plan that we cannot fathom yet. What we're responsible for is using our onboard system, not the emotional system of love, joy, whatever, but the rational system. That puts us in contact with the universe, which is rational, as we now can prove. So, with this rational space called spherical space, we have a center with nothing inside. Because what's inside is 1 over infinity and an imaginary number. This is a contradiction, but we will solve that. But you have to be patient, because it's a monumental paradox. But there is a rational solution, and I'll show it to you now. Space goes out. That's tautological. Nothing is inside. We have a sphere with nothing inside. What does that mean? We'll get to that. It has to do with force balance. The proton manifests that sphere, and it's the only particle that does so. This baffles us because protons are everywhere. So there's always going to be two sides to things. The edge is everywhere too. That baffles us because we're very limited, but we do have a rational mind which we can use to synthesize a new perception. A lot of our brain is unused, and I believe this is what it's for. So the problem is time. Albert showed that time is related to space. What relationship is that? Orthogonality. An orthogonality is a 90-degree angle, not 180. 180 degrees is plus minus, but orthogonal is something different. In spherical space, we can see what that is. Light does propagate spherically. Well, so does gravity. But gravity is induced by the protonic system, which has a centripetal force with respect to the electrons. So the electrons collect around the protonic core and form shells with quantum radii. In other words, they don't vary. They don't go in between the shells. They only go to the shells, which are quantized. Gravity does not seem to do that. And I wish to emphasize, gravity does not seem to do that. The basic reason why gravity appears to be uniform is because gravity is an integration of protonic force. The protons collect together because they do exert an attractive force, the atoms will collect. And we see that in the moon is a sphere, the earth is a sphere, and stars are spheres. That's because of mass, its effect on itself. How do these spherical objects form? Well, we're not sure, but we have some theories about that. But as things exist, just de facto, we have spheres. And that's why. It's because the proton bends space. But what does light do? Light does not seem to affect space. Protons do affect space. You can think of it, and Albert taught us to think of it this way, that protons bend space. Well, that's a spatial effect. So the proton is a spatial particle. What is the electron? That is a magnificent question. The fermion electron is considered to have no radius. You can look that up in Wikipedia. You would have to say it can be conceived as a particle since it can be fired from a gun. The nature of the proton is that it occupies a center of space. An electron does not do that. What does it do instead? Well, it does respond to the presence of a proton or more than one proton in a nuclear center. So the electron has a different dynamic. It has a different mechanism. We're going to find out what that is, but I don't want to make this confusing, but I do want to show you that this is integrative and synthetic. We're going to be able to answer a lot of questions at once with this geometry. So let's return to the geometry and see what's missing, because something is missing. We know now with our number system that we have whole numbers that we can conceive of as going out. Any one of those lines, if you reverse direction, that's a 180-degree reversal. However, Einstein showed that that's not actually the case. It's a 90-degree angle in spherical space, and here's how we can discover that. When you have a sphere that's not rotating, geometry does not incorporate motion. In fact, geometry does not incorporate time, and all of our equations up to the present day deal with time as having a value of 1, and that's where we get light speed. It's a value over 1. It's distance over 1 second, but the second is arbitrary. We've chosen it for conventional reasons because it is considered to be an exact fraction of a solar year. And you may think, well, that is arbitrary. Yes, it is, but it's very convenient. But Albert Einstein taught us that time is actually a data type, and he linearized it. When he did so, he inverted the valence. And the only way you can do that with a linear number system is the 180-degree valence of plus minus. So he made time negative. The 3 spatial axes are positive. They have to be to get linear spatial separation. That's always plus 1. It doesn't go negative. Distance is positive only. Now what about time? He worked it in there, but on a 180-degree valence, where the 3 spatial axes are positive, the imaginary axis is negative. That works for the same reason that complex numbers work, but it requires a special algebra called quaternion algebra, which is a variant of complex algebra. And those are the only 2 possible algebras in linear dimensional space. You know that linear dimensionality for a flat space is 2D, the line itself is 1D, and cubic space is 3D, which is all we've ever used in science. But to get curvature, you need special tools. We've invented sine cosine for the plane, and we've used calculus to get everything else. This is where we get partial derivatives and all kinds of interesting forms of their averages. They're averages in flat space of 2 numbers. Sine and cosine only work together using the Pythagorean theorem. That's a very abbreviated encapsulation of what imaginarity does for us. In other words, the negative numbers have served us because the square root of -1 introduces a circular function using e. E, you may know, is a magic number. It's irrational, but with calculus, you can get things as precise as you want. All the calculus texts just repeat over and over again, as precise as you like. That works on Earth. It does not work for cosmic space, because the universe is balanced, and irrationality simply does not exist. So far, our new number system is entirely rational. The center, which replaces 0, is 1. That's a multiplicative identity. It does not affect division and does not affect multiplication, to the same proportion that 0 does not affect addition nor subtraction. But add only works on the line. Multiplication and division work in the system we just invented. And there is no 0. There is no division by 0. 0 is a derivative number. In fact, the linear numbers are derivative numbers of the spherical number system. So the spherical number system is antecedent. It is rational. So the center of the system is the surface of the sphere. That's a radically new notion. However, a moment's thought should tantalize you. We're starting to address a lot of paradoxes. So now we have two-component numbers that fill space. When you have the surface, which is the center, it's harmonically balanced between the center and the edge. That is the number 1, because unit fractions go in. Well, they don't go in. That's the secret. Albert unlocked this for us. The numbers going out make shells. They're quantum shells. Now, it can be as fine granularity as you want, depending on how you normalize it, but these are quantum jumps. And I forget the name of the physicist who said, "Oh, these jumpy. I don't like all this jumpy." Well, what the physicist was talking about in his complaint about the jumpy is that when a photon detaches from an electronic system, it's not a continuous function. It's a step function. And Max Planck proved that. That's the quantum number system. That it begins at 2. Because 1 is the normalization. It doesn't normalize to 0 as it does in the linear system. 1 and -1 add to 0. Plus infinity and negative infinity add to 0. That's the Archimedean balance point for the line, which is the derivative of the radial line. Now that forms spherical space with a radial line, and the sphere is perpendicular to that line. Therefore, the fractional number, which would be wavelength in this case, 1/2, does not go in towards the center in Zeno's paradox. The solution to Zeno's paradox is a particle approaching another particle cannot collide with it, and Ruger Josef Bošković proved that. Particles do not collide. What they do is something very strange, having to do with two infinities and the right angle between them in spherical space. So here's our sphere, which is not rotating. To generate the first counting number, the index number, equivalent to 1, in this case is 2, but it's a split 2. It's 2 this way and 2 this way, perpendicular. It can't go in. There is no in for real particles. A particle such as the proton has no interior. That is a paradox, but mathematically we proved that it's rational. That is the quantum. So the proton is a manifestation of the quantum. And the shells that it forms around it are written into view by the electrons that only go to those shells. Those are space shells. But what in the world is an electron then? It's pure motion. So now we need motion. And that's rather easy to do. We have a sphere, rotate it. That is the introduction of energy into the universe. The Big Bang does not account for this. The Big Bang is rather naive, and I think you can see why. The rotary component on the sphere is motion. That's called angular momentum. And properly speaking, you can say that that is the only proper motion in the universe. Hold that thought, because you might think, what about a straight line? That's a very special case of a curved line, and it can be said that no line is straight in the universe. But only once you've understood force balance. And here's the way to get at it. When the sphere rotates, it still has the same spatial characteristic, because the sphere does not move. In space, it's not moving up, down, sideways, back, or forth, but it rotates. So that keeps the spatial system as it was. Although you may have a question about that. Doesn't that curve space? Yes, it does. That is, space itself is rotating. We don't see that, and don't worry about that, but I just wanted to address that question so you know that nothing's being left out here, but this is an extraordinary paradox to get at. We have part of it. The sphere itself, when the numbers are being generated from 1, the whole number, which we consider to be the frequency component, those are whole numbers. 2 over 1, 3 over 1. Those are quantum jumps, demonstrated in the construction of the Bohr atom, but there are other proofs of that. And that is spatial. It's purely spatial. Now, the sphere being rotating, that is where the unit fractions turn. So as 2 goes out, the other 2 is manifested on the ring, which is what we would call the equator of the sphere. This is where we get the spin component of particles, which, as you know, can have half spin or integer spin. And some particles are considered to have 0 spin. We'll get there. But that half and that whole, that is integer spin and half spin, manifests the difference between the circle and the sphere, which geometrically is a 2-to-1 ratio. I show that to you. We have always thought of the circle as being tau, and we always use half of it, pi, because that's the upper positive half. It makes it easier to compute things. And the reason we use the first quadrant is because both x and y are positive. But actually, pi is a convenience number for the entire circle is tau, 2 pi. The circle is tau, but the sphere is 2 tau. When we use our spherical number system, basically the 0, that is the center of the system, is no longer the additive identity of 0, which is strictly for the line which only uses add. But the sphere uses multiply. So when you compose the numbers the way we did, making the infinitesimal 1 over infinity, an imaginary number, and the edge infinity over 1, another imaginary number, they multiply to 1 and cancel the infinities to imaginary space, which is critical because you can't use it. You can't reach it. You'll never reach the center because you can't reach the edge. And you can't reach the edge because you can't reach the center. And both numbers in the 2-component system are trying to reach both, but they can't reach either. So it's finite. We have not yet discovered the upper limit for frequency. And there may, for all we know, it may be infinite, in which case the universe might be infinite. But nobody's ever proved it one way or the other. But there is a lowest frequency, 2, and there's nothing lower than that. It might be harmonic. It might go 2, 4, 8, 16. But either case, they're rational numbers. They're whole numbers. For frequency, when frequency is normalized, they're whole numbers. That means that the reciprocal, which is the wavelength, is a unit fraction. Now, not all unit fractions are rational numbers. 1 over 3 is not rational in linear space because you can't represent it in a computer. It has a period 1 repeating decimal of 3. And 1 over 7 is even worse. It has a repeating decimal of period 6. It's 142857. 142857, 142857. That's not rational because it doesn't end. So not all unit fractions using our linear number system are rational. But 1 over 2 is, 1 over 4, 1 over 8, 1 over 16 are all rational. They all are computer representable numbers. They're called the representable numbers. 1 over 3 cannot be represented on a computer, and you can check that in the IEEE. By the way, neither can 0 unless you split it into 2 parts. So, all of this is to say we have a much better number system now. There is no division by 0, and there are no irrational numbers. But we still need the metric, but we have a 2-component metric. One of them is space. We just discovered it. The first jump is to 2. The next one, 4, 8, 16. Just think of it that way. It's close enough. We're not positive about all these things yet, but obviously this makes sense. Now, what about the unit fractions? 1 over 2, 1 over 4, 1 over 8. We would think of those linearly as going in. Zeno's paradox tells us it can't reach the center to the proportion that it can't reach the edge. But Einstein says it doesn't go in, it goes at a right angle. That is the sphere. And when it rotates, that is energy, that is motion, and what we're going to discover now, that is time. And that explains a lot. So as the sphere rotates, it has a period of rotation called its periodicity. It keeps coming back and back and back. When things go out spatially, they don't come back, they just go out. That's the propagation of light. But as light propagates, there's a reciprocal effect in time, and that's manifest on the sphere as a proportional number. Because you can see that as 2 is bigger than 1, it forms another shell, and the shells go out, that's spatial. On the sphere, that 2 divides the ring into period 2. When the shell is 1,000,000, the ring is divided into 1,000,000 parts. And that's the relationship, the direct relationship between frequency and wavelength. So wavelength can be considered the time component, and that is manifest on the surface of the sphere. So now, if that is true, and we're going to attempt to prove that, we have the space-time metric on reciprocal proportional numbers, which Einstein said we're going to need now. And these are 2 different data types. Now let's concentrate on space and time. We're oriented towards space, but we've never been able to orient towards time. I want to give you a little secret of the universe that comes out of this, just to tantalize you here. Because of what Einstein was forced to do to linearize time with space, he had to curve them both. That's why space-time is said to curve. However, that may not be true, and in fact it's not true. Space we know is curved, if we choose to look at it that way, which we do, because gravity pulls space in. The proton curves space. The way the electrons behave proves that space itself is curved around the proton. When the protons form a mass like the Earth or the Sun, it forms a gravitational field that's in every way analogous to protonic centripetal force. And these are the only 2 centripetal forces in the universe. They're obviously related. That's how they're related. A mass system is a protonic integral system. The protons basically form a field together, but it's protonic force that's pulling space in and manifesting the force of gravity. That's spatial. Now light is centrifugal it goes out. It doesn't pull space in. It goes out apparently through space. But how? It goes out through space spherically. So it's the exact inverse of gravity in that sense. But Sir Roger Penrose stated it extraordinarily cogently when he said, the photon does not experience time. And light speed is the speed of a propagating wave in spherical space. In other words, it's going out through space as space is being pulled in by the protons. The detachment from the electron, which is a different particle, goes out. So the electron is manifesting a non-spatial component. That is time, and that is motion. Time, motion, centrifugal force, and energy are not spatial concepts. They have to do with the periodicity on the ring. It has to do with motion, angular momentum, and that is the manifestation of time, but it's linear with respect to space. So as space is curved in, time is centrifugal out, and that explains why we can't imagine the edge of the universe. Here's why. As you keep looking out through space, the volume that you're looking at is going out basically conically. So it's actually going hyperbolic as you look out. This is where the hyperbolicity comes in. And as your mind attempts to penetrate to infinity, you lose track of time. Because the volume of space is getting so large that it would take you more and more time to see it. And that is the centrifugality of time. Space is manifested as centripetality, if that's a word, I believe it is. So space only goes in, but time only goes out. And that's why it feels linear. It is linear. And what Albert did was he bent it so that it bends with space. And from that, using pseudo-hyperbolic geometry with fourth tensor calculus with a gamma term, which a human can't even compute, although Albert could, we use supercomputers to do it so we can navigate the solar system. So it does work. But only because with calculus you can get curvature down to an infinitesimal as small as you want, and that'll work for your rockets and your guidance control inside the solar system. When you're trying to compute universal space, it breaks down because as space goes out, no matter how small you make your infinitesimal for curvature, you cannot infinitesimalize infinity. We already just did. We began our system by infinitesimalizing infinity. And that's an hour. We'll be back with more. There's a lot more to come. We're going to discuss the flight of the photon, imaginarity, imaginary space, and space-time and time-space, so that you have a grasp of both quantum mechanics and cosmology to cut through the linear lines. It doesn't work, and calculus does not work. It works on Earth, doesn't work in the universe. It's Anagalactic.